So next, I would like to introduce Maria, who will be presenting simulating networks in your laptop. Maria is a computer and internet witch, serving as a team leader and low-level developer at CZ.NIC, and traveled from Prague, Czech Republic to join us today. And this is Maria's third time presenting at NANOG. Her first talk at NANOG was a lightning talk called Board 1 End of Life Announcement at NANOG 989 in San Diego in 2023. Welcome back to NANOG, Maria.
Hello. Yeah, that works better. Thank you for coming here. I'm Maria. This is a presentation about a work which is being done for like 9 years. And we were doing this like quietly since 2015. And well, we didn't know, we didn't think that this would be of any interest from the community. But after some time, the container lab came in and people started using it. And after looking at lots of the presentations, I decided, well, we should probably present at least once or twice about what we are actually doing and what we can do. The time is doing strange things. Now it's better. Thank you. Yeah, so this is basically, if you are familiar kind of with Container Lab, this is something quite similar. It's a tool which you run. Well, you don't need any clouds or anything like that. You just run it in your laptop, and yeah, let's dive into it. How it actually is used, and at the end there is a link where you can actually try to download it. Please beware, it's a thing in very this version which is linked is in a very intensive development, so please expect it to break. Well, yes. How to start? You first, let's say we want to start. We want to simulate two machines with one link. So we start a simulation, we call it test. Then in the test, we create a machine named A. Then we create a machine called B. And then we create a test link. And it creates this. And after this, it starts and exists. What it is doing, it's opening just network namespaces, PID namespaces, user namespaces, and so not using any image on your machine. So it uses basically your hypervisor, which means your laptop. It shares the disk completely. So it's not intended for production use. But if you want to teach people how the routing works, they don't need those images, those isolated environments. They just need some IP stacks. Yeah, and then you can log into the machine. So you just run shell test A, and yeah, the shell is that you want a shell. Test says that it's the test environment is the name of the suite, and the A is name of the machine. And if you are familiar with this thing, yeah, it is using Telnet. We were trying to use SSH. We failed because we don't have two things. We are running this in an unprivileged container, which means we can't do set groups on the side of SSH. And the second problem is we are not having that that isolated environment. So SSH needs some files and places in the file system to to be reserved for them. And if you run 5 SSH daemons, it doesn't like they don't like themselves. Yeah, so running telnet works. It actually opens the port just for the session. So you can see 64122, but I don't know. I don't remember whether it's implemented in that public version. But we already started rewriting it to another version, and there it's like you connect once and then the port is closed. So the possibility that somebody else actually logs to your machine is quite negligible, and also it listens only on localhost. Yeah, so this is the telnet, and you are getting a fake root, which is a root for that environment and nothing else. You can show that there is indeed that link, that test link. So after that, yeah, there are actually a test link on one side and on the other one. You can show the addresses. You automatically get the IPv6 link local network address. And so what you can do actually is you can just ping the local. You can ping the link local address from the other machine, and it works. You don't have to set up any IPs. It just sets up itself. Or you can actually add some addresses. So you just add some. You add the routes. You have to add them statically in the first try. Or what's that? I think I have lost a slide. Anyway, you can add this, and then it just pings on those addresses. Or you can actually set up some routing daemon using the shared file system. Means that you can have one common configuration and then just include it from 2 different configurations, and you don't have to write so many letters. So this is the complete configuration for OSPF running at 2 nodes. At the bottom there is the common part, and at the top you set the router ID and include the rest, because the rest is the same. Yeah, and with that we can simply add a new node. We add another machine. We don't have to tear it down. We just add another machine from the command line. We add another link. We add another birdconf. And we run bird. And after that, well, yeah, we actually have to add one more IP address. Yeah, and then it runs. And you have a routed network. You may have to fix some problems, like in some situations, some distributions don't like to set your forwarding options to 1. So you may have to enable IPv6 and possibly IPv4 forwarding inside those virtual machines, one after another. It isn't possible to set it globally. And also, I ran into problems with TCP dump, which is well, in Debian, TCP dump is forced to run as a different user, and you don't have a different user, don't have a different group, because you are having just the root in those machines. So I had to rebuild TCP dump from sources. It's not so hardened, but well, we are running on my laptop, actually in a constrained environment. The root is a fake root. It's just my user behaving as a root in its own namespace. So I don't care. I can run TCP dump non-hardened. We can run FRR. So if we wanna remove that bird config for the machine B, this is the FRR config for the same machine. And yeah, we need a little bit more because FRR does not like running doesn't like running twice or more times locally. So we have to bind mount something, and we have to run actually 2 daemons instead of one. Also, we are not running systemd inside that. It's just our very simple init. So you should not expect systemd working, at least for now. This problem is going to be much simpler in the new version, where we are actually going to add an option where you get a completely writable root file system, which is just an overlay over your your major file system, over your, let's say, hypervisor over your laptop. But yeah, it will help running FRR a little bit smoothly. And what I can do, well, I can run 200 machines, because all of those machines are just a Python script which eats like 25 megabytes. So let's run 200 of them. You can start them just by a script. You can script it in Bash or whatever you want, and run 200 machines. And well, this is not making that ring. This is just making that 200 machines. Don't count the rings. Don't count the circles. There is not enough circles on the image. Yeah, you have to prepare the configuration. I'm again using that trick with having one common configuration, and that router ID will be set in the specific files. So it's just, once again, the device things, the kernel thing, and the OSPF thing. Yeah, we have to prepare the specific configuration. So we just set the router ID and include the rest, because the rest is the same. And yeah, it's you can see here that there is quite a long path. This can be actually configured, but I'm using /run user UID flock and then some subpaths for this. So if anything goes wrong, you can just completely delete that /run user UID flock. You can delete the directory. You can kill all those Python scripts, and everything is clear. I will add probably a cleanup command, but basically deleting this and killing all those flocks is okay. Yeah, then we have to run all the machines, run Bird on all those machines. There is a sleep actually to not make problems with reading all of those files from disks and so. And also it's running, it's setting, you can see that forwarding is setting to 1, and there is the IP address added for every single node. Yeah, and again, you can see that we are adding only the IPv6 address. We don't need IPv4 anywhere, and we don't need any management network as well. It's just completely isolated, and if we want to connect to it, we just get that telnet socket, which is magically passed from inside to outside. Yeah, you can also see that all of this is passed into that. You can see flock.py shell test, which means you are running this on those machines one after another. And after that, we haven't yet linked those machines together. So yeah, we just create those 200 links, and it makes them. And yeah, after that, you just show the routes on one of those machines, and it is actually showed. So you can see that, well, this is truncated. There are lots of, there are more of these routes. There are actually 200 of them. And this is on the machine number 1. And this is the middle of the dump, showing that actually there is 626364. It's hexadecimal. So 64 is actually 100, and 65 is actually 101. And you can see that 101 is on the other side. It's the precise opposite. So 1/2 is going one way, and the other half is going the other way of the circle. If we look at the circle once again, which is like here, this is the number of machines is even, so there will be one machine on the other side, which will be reachable from both sides equally. So this is what happens. Yeah, and we are back here. And some of you probably now know what's going to happen with this. I overshot. So this is too far. The ring is too big. And the OSPF actually knows that behind all those nodes, there is the target. But, well, I don't have the TTL. So, yeah, and if I set the TTL locally for the ping to more, the ping from the other side gets still TTL 64. Yeah, it can be set in SSS's CTL, but I use this to show something else. It's actually quite an unreasonable network. You won't see any network like this in real world. So I made the network a little bit more unreasonable, added some spines, and yeah, it's just another bunch of commands saying, well, please add some nodes, and these are added. And you can this way modify the topology every minute. You can drop links, you can add links. Well, you can't drop links now, but it's like in plan for the next release. You can add links. You can set links down, up, just for dynamic testing of any scenario you are looking for. Yeah, and after adding these spines, yeah, the ping works. And it has actually quite a short TTL, because what I wasn't thinking about was that, well, the trace route now looks quite crazy. It actually is mostly using those spines and sometimes jumping backwards. Yeah, because the OSPF just found the best route. So, yeah, the shortest path actually goes very crazily around, because yeah, I did the worst thing I could do. I let the coasts of the links completely equal. If this was different, I should have probably set those links to quite some higher number. But yeah, this is to be set for the specific situation. Yeah, but you can configure lots of things. We also have a Python package, so you can include this into your testing. You just import it, create something, it's called hypervisor, and then you just create a machine. This script runs, this script creates 5 machines. And in the machine C, it then shows the IP addresses. Yeah, so you can use programmatic ways to control it. Yeah. The thing is, we were thinking about using full-scale virtualizations and containers for quite some time, and we are traveling quite a lot, and we actually don't have so much hardware for testing, so we just went with what we had. So this is a tool which fits well into my laptop, and I am well used to running it on the airplane. So I'm going to run it this evening after I sit into my sit on the airplane and departs. It can run hundreds of accessible nodes, and underway is another rework which should reduce the memory footprint from tens of megabytes to actually several megabytes per node. So, do you have 16 gigabytes of RAM in your laptop? Well, you can run 1000 nodes and nobody cares. And you can test those big scenarios just on your laptop, even offline. Yeah, it's repeatable, it's automatable, means, yeah, you have the Python package. And it's purely non-root, which means you don't have to install anything. Well, apart from in the situation of the version which is currently public, you have to install like several packages like netcat. Is it netcat? Oh, it's socket, but it's. You can also just download it locally and build it. But it's purely non-root. You don't need any root access anywhere. You don't have to use like university things. You can just say to the students, well, not now because it's still in development, but when it's stable, you can use it when teaching people how routing works. And if the network goes down, you can continue teaching. If the cloud goes down, well, you don't have the cloud. The cloud is in your laptop. Yeah, there is a line for credits, which is for Ondřej, who actually wrote the original NetLab, which this is based on. The original NetLab is just a bunch of bash scripts, which we are now reworking. Yeah, what we are expecting to do is adding support for more full-scale virtualization. So if you need a Docker image inside it, for example, to check another distribution or to check different builds, yeah, why not? This may need some root. For example, if you want to run QEMU, you may need root for this, or you may need root at least for the KVM part. We are thinking about making a clickable GUI for this, which is, yeah, if somebody is very interested in this, please come to me and we can consult how the clickable GUI should actually look like. We are expecting to add like a native support for simulating packet loss, latency, such things. Actually, we need to test Babel inside this. And with the routing protocol Babel, well, you are simulating Wi-Fi. And we wanted to simulate how the packets are behaving on Wi-Fi, so there will be something like that. What's funny is you can not now, but basically in very hot plans, it's to interconnect multiple instances. So you can teach all your students about OSPF. You can let them create their own networks. And after a while, you say, well, and now you can interconnect your instances. Every of you is an AS. and now we are learning BGP. And you are doing actual interconnections between your networks. We are also expecting to connect physical machines. If you want to test this, let's say, against a Nokia router or a Cisco router or anything else, why not? Yeah, you can try this at this website. It's our GitLab. Beware, this is not a thing you want to run in production. This is basically an early notification that something like this is happening. And yes, we are crazy. We are reworking this to see, because, well, we want the memory footprint to be minimal. We don't want 25 megabytes of Python for every virtual machine if the rest, which we want to run there, is BERT, and it runs 3. So it's quite stupid to eat 25 megabytes of RAM for 3 megabytes of BERT. Yeah, it's quite in high development phase, so the UI and API are going to change. Anyway, if you find anything useful with it, if you like to contribute, well, let us know, and we are going to speak to you, because we'd love to give this to the community and say, probably even say, if you have a problem with BERT, you could simulate it in this environment, and then you can just pack it and send it to us, and we are going to reproduce it locally. Yeah, and that's it. That's me and where you can contact me. And if you wanna know more about this, there is the BERT users mailing list and BERT support at CZ.NIC CZ. Thank you.
Thank you, Maria, for the presentations. Are there questions? Please go ahead. Yeah.
Hi, Chris Woodfield, currently unaffiliated. Just to clarify, what OSs are supported? Does this require a Linux VM, or is it OS independent?
I haven't said it, but it's expecting Linux. Sorry, it's not expecting BSD, because BSD jails are too strong. It's using Linux's unshare feature quite massively, and it actually does quite some magic with unsharing partly and then partly once again to create some parts which are inside the virtualization and some parts which are outside.
Okay, thank you. If you'll allow a follow-up question, I'm digging up a fuzzy memory of having trouble forwarding multicast packets between VMs on a bridge because the destination MAC of multicast is in a mask that the kernel won't forward by default. OSPF uses multicast. Is this something you've run into or have any idea about?
For all those years, we are using this kind of pseudo virtualization. We have never seen these problems anywhere.
Okay.
Which means we may have not run into it, but if you have any specific scenario, just let me know, drop me an email. We'll look into it, because if that's a bug in the kernel, we are also willing to contribute to the kernel to fix it.
Okay. I've been trying to Google to refresh my memory, but so far unsuccessful. All right, thank you.
Thank you.
Gary Geeson, eGate Networks. Is your planned like container support and KVM support, I think you mentioned, is it still mostly focused around working with Bird, or are you going to start branching out similar to like Ivan Pepelniak's NetLab project, where we'll run like iOS containers and Junos containers and whatever, or is the focus going to stay mostly around Bird?
Honestly, the major goal with this is for us to have better testing facility for Bird. But part of the testing is actually interoperability. So we need to run all those images, run those Cisco, I don't remember those letters, sorry, run those Cisco images, Juniper images, whatever you find handy. We are expecting to connect physical hardware to this because of the interoperability testing. So yeah, it should be in the end quite universal.
Okay, thank you.
Hi, Mark, CZ.NIC. Great presentation. Of the features that are coming in the future, is there like a roadmap as to what you're prioritizing from those? Like, because everything you listed on there is something I would want extra from this tool, but I think bridging to another topology is probably would be the top for me, something I would hope to get soon.
You are speaking about those interconnecting those instances?
Like, for me personally, I would deprioritize things like trying to rebuild GNS3, and I would try to go towards the packet loss, latency, bridging to other topologies, because the power for simulation learning is very powerful with this. But in terms of automating a large WAN or a large simulation and then plugging that into a device we don't like so much and seeing what happens with it, that's a very powerful use case.
Well, the priority of these 5 items is basically 4, then 2, and then probably 3, 5, and 1 we don't know. The thing is, we want to use this for teaching about the dynamic routing the next academic year.
Okay.
So we need to interconnect the instances to actually make use of this for teaching about BGP, because part of the BGP teaching is to teach you that you actually don't have control about the other side. If you are setting up eBGP with your peers, you have to do some negotiations, and you are in control of your router, and the other side is in control of the other router. So we need those interconnections, and the clickable GUI is to just lower the steep learning curve.
Yeah, indeed. If I can just make a follow-up comment. Well, then I think the top one for me would then be number 1, where you can use something like BNG Blast or another T-Rex or something like that and try to inject things and see what happens in that topology, right?
Yeah, the first point is actually quite a hard thing, because running Docker like let's say natively is not what we want to do, because Docker pollutes the environment quite a lot. We are basically looking for a possibility to run like C or Docker like inside our means without actually running Docker.
Right.
Let's see where it brings us. Maybe we say we failed. We may fail. We don't know.
I think you've already succeeded in what you tried to do already, so that's pretty good. So thanks for bringing this.
Thank you. Looks like.